Hello everyone, today we are discussing the laws in chapter Laws of Motion from NCERT. I will be going through the exercises that is given in the chapter one by one. If you have any doubt, you can simply comment in the chat box and I will entertain your doubts. So let's come to the first question. It says that give the magnitude and the direction of the net force acting on the raindrop falling down with a constant speed. So here the question is saying we have to find the magnitude and direction of the net force. So here the question is asking about the net force. So let us consider all the 5 scenarios that are given. So in the first scenario, it is raindrop with a constant speed. We know that when a body is traveling with a constant speed, then it is not accelerating except it is in the circular motion. So here we can say that net force is 0. Net force is 0. And in the second scenario, we have a cork of mass 10 gram floating on water. So again, the case is of balanced force because the cork is experiencing a net 0 force, and that's why it is still floating on the water. Otherwise it would have either accelerated downwards or upwards. So the case here is it is floating on the water, so we can say that the net force is 0. And in the third question, we have a kite skillfully held stationary in the sky. Again, if the body is stationary, then the net force acting on the body is 0. That's why it is stationary, or the forces are being balanced. In the fourth scenario, we have a car moving with a constant velocity of 30 km per hour on a rough road. Again, the body is moving with a constant velocity, so we can say that the net force is 0. And in the fifth option, we have a high speed electron in space far from all material objects, free of electric and magnetic field. So the question here mentions that it is free from all material objects, that is, there is no any gravitation acting on this body, and free from electric and magnetic fields. It means that there is no any magnetic field or electric field acting on the body, so it is experiencing 0 force. Let's go to the next question. So in this question, we have been given that a pebble of mass 0.05 kg is thrown vertically upwards. Give the direction and magnitude of the net force on the pebble. So here pebble is thrown upwards, so we have to give direction and magnitude of the net force. So once the body is thrown and the throwing agent has detached from the body, then it is on its own, and we can say that it is under the influence of gravity and no other force, because there is no any self-propelling machine on the ball, on the pebble. So it is under the influence of gravity. So during the upward motion or during the downward motion, or when the object is on the highest position, it is all experiencing the gravitational force, and that's it. We also need to give the magnitude of net force. So magnitude of net force is simply the mass times acceleration due to gravity, and that would be equal to 0.05, and taking the value of g to be 10 meter per second square, we would come to the conclusion that 0.5 Newton force is acting on the pebble. Do your answers change if the pebble was thrown at an angle 45 degree with the horizontal direction? Ignore air resistance. So again, once the throwing agent has detached from the body, then it comes under the influence of gravity, so there is no any change in the magnitude of net force, so the answer would be same. The third question is, give the magnitude and direction of the net force acting on a stone of mass 0.1 kilogram. So again, this question is very similar to the previous question, but here the body is on the train, which is stationary in the first case, and in the second case train is moving in the constant velocity, and in the third case just after it is dropped from window of the train accelerating at 1 meter per second square. So when the body gets detached from the train, the net force acting on the body is of that of the gravitational force, and it's experiencing a force equals to mass times gravitation, and it would be equal to 0.1 kg times acceleration due to gravity, that is 10 meter per second square, and that would give us 1 Newton. The second scenario is just after it is dropped from the window of the train at the constant velocity of 36 km per hour. Since the train was running at the constant speed, and also when the stone gets detached from the train, it is under the influence of gravity alone, so the net force acting would be the same. In the third scenario, we have just after it is dropped from the window of the train accelerating. Again, the scenario is same. The body has been detached from the train, so the answer would be same. And the fourth scenario is lying on the floor of a train which is accelerating at 1 meter per second square. So here net force would change in this scenario because the stone is stationary on the train. So the gravitational force is counterbalanced by the reaction that is being applied by the floor on the stone, and since it is accelerating with 1 meter per second square, so net force would be the mass times this acceleration, or 0.1 Newton. So let's go to the next question. In this question, we have one end of the string of length L is connected to a particle of mass m, and the other to a small peg on the smooth horizontal table. If the particle moves in a circle with constant speed v, the net force on the particle directed towards the center is. So we have to give the net force when a particle is rotating on a table. Let us assume that this is the center of rotation and this is the particle, and it is rotating like this. So we have to give the net force on the particle given that T is tension in the wire. So the first option is T, that is tension alone as the net force, and the second option is T minus mv square divided by L. So here mv square by L is equals to the centrifugal force that is acting away from the center once we see this particle from the non-inertial frame of reference, and this in the third option its direction is just changed, that is T plus mv square by L, and the fourth option is 0. So in this question we see that this option can't be there, that is there is 0 because since the body is moving in a circular direction, so there must be some force that is making the body move in the circular direction, otherwise it would have followed its own path, that is a straight line, as the Newton's second law of motion says. So there must be a force that is binding the object to rotate around the center. So fourth option can't be there, and these two forces can't. So second option and third option can't be there because the force that is balancing the pebble to move on the circular path is tension. The force that is binding to move on the circular path is tension, and it is balancing the centrifugal force that is acting with the magnitude of mv square by L. So the net force that is acting on the particle is T. A constant retarding force of 50 Newton is applied to a body of mass 20 kg moving initially with the speed of 15 meter per second. How long does the body take to stop? So in this question we have been given the initial speed of the body, and we have been given the mass of the body, and the retarding force is also given, that is of 50 Newton. So this scenario can be physically resembled with a body, a vehicle of 20 kg has applied brake. It was moving with the initial speed of 50 meter per second, and the retarding force caused by the brake is 50 Newton. So we have to calculate how long will the body how long will it take to body to stop. So we can use this equation of motion here, but before using the equation of motion we need the value of acceleration, which can be calculated by the given force and mass of the body. Since we know that F equals to ma, so we can simply divide force by mass and we will get the net acceleration. and since the acceleration will be negative because the force would be retarding in nature. So after that we can use the formula S equals to ut plus half at square, and we will find the solution. In the sixth question, we have a constant force acting on a body of mass 3 kg changes its speed from 2 to 3.5 meter per second is 25 seconds. What is the direction of motion of body remains unchanged? What is the magnitude and direction of the force? So in this question, we have been given that mass of the body is given and its speed is changing from 2 to 3 meter per second, that is, it is accelerating, so its acceleration is going to be positive, and we know the formula for finding out the acceleration. It is change in velocity by time. So we have change in velocity, that is 3.5 minus 2, and when we divide it by time we will get the acceleration, and acceleration is positive here. And when we get the acceleration, we can get the magnitude and direction of force as the mass force is mass times acceleration. The question here is a constant. So we have discussed this question. Now let's move to the next question. A body of mass 5 kg is acted upon by two perpendicular forces, 8 Newton and 6 Newton. Give the magnitude and direction and acceleration of the body. So here the scenario is like this. A body of 5 kg is there and it is acted upon by two force, 8 Newton and 6 Newton. So we have to find out the resultant force and its magnitude and its direction. So since force is a vector quantity, we can do vector addition over here. So let us assume that this is vector A and this is vector B. Let us align this vector. So this would be vector A of 8 Newton and this would be vector B of 6 Newton. Since the head of the one vector will align to the tail of the second vector, so we have aligned like this, and the resultant vector would be something like this. So since it is perpendicular to each other, we can easily find out the magnitude with Pythagoras theorem, that is 10 Newton, and its direction would be tan of the value of 6 Newton by 8 Newton. So moving on to the next question. In this question, we have a driver of three-wheeler moving with a speed of 36 km per hour sees a child standing in the middle of the road and brings his vehicle to rest in 4 seconds, just in time to save the child. What is the average retarding force of the vehicle? The mass of the three-wheeler is 400 kg and the mass of the driver is 65 kg. So here we have been again given the question that was previously asked about the 50 Newton force, 50 Newton retarding force that is being applied on a 20 kg object. So here we have a different scenario. The mass of the vehicle plus driver is given, that is of 400 plus 65 kg, and since the mass and since the driver is inside the vehicle, the three-wheeler, when it will be applying brakes, so both mass will be taken into account, and the initial speed of the vehicle is 36 km per hour and it has to stop in 4 seconds. So we have to find out the retarding force. So retarding force we have to find out, and mass is given. So we just need the retarding acceleration, because force is mass times acceleration. So in order to find the retarding acceleration, we need, according to the equation of motion, we need the change in velocity and time. So we have change in velocity, that is from 36 km per hour to 0 km per hour, and we also have time, that is 4 seconds. So when we find out acceleration using this data and find out the acceleration, we will simply multiply it with 465 kgs and we'll get the force in Newton. So if you want, how do you get 10 Newton? So upon vector addition of this graph, vector addition of these two vectors, we will get 10 Newton. The formula for vector addition of two graph is, in this scenario, it would be the magnitude of the vector, resultant vector would be equal to under root of a square plus b square. So the general formula of the vector addition is, magnitude of vector addition is under root of a square plus b square plus 2ab cos theta. Since theta is 90 degree, so it is going to be 0, and so it is going to be 8 squared 64 and 6 squared 36, and it would be equal to under root of 100. So we will get 10 Newton. That's how we will get 10 Newton in this question. I hope your doubt is clear. Now we will move to the next question, that is 4.9. Now in this question we have been given a rocket with a lift-off mass of 20,000 kg is blasted upwards with an initial acceleration of 5 meters per second square. Calculate the initial thrust force of the blast. So here we should understand the scenario over here. Like when a rocket propels upward, then it ejects huge amount of gas, or whatever fuel it is running on, and the reaction or the thrust force is given upwards. So here we have to calculate the initial thrust if the acceleration is 5 meters per second square. Now since we know that the mass of the rocket is given and it is not changing, so it is the mg, that mass of gravitational force would be acting downwards, and the reaction force that is needs to counter the gravitational force plus 5 meters per second square the inertia. Let us assume that T is the thrust over here and mg is the gravitational force that is acting on the body. So T minus mg must be equal to 20,000 kg times the 5 meters per second square acceleration. Now if we calculate this, we will get the value of the thrust that is required. So here the T would be equal to 20,000 multiplied by 10 plus this net acceleration, that is 5 times again 20,000. That's how we will get the value of thrust. Just wait a second. Now moving on to the next question. The body of mass 0.4 kg moves initially with a constant speed of 10 meters per second to the north, is subjected to a constant force of 8 Newton directed towards the south for 30 seconds. Take the instant for the force applied to be t equals to 0. The position of the body at time t, we have to calculate the position of the body at time 0, -5, 25 and 100 seconds. So from the start of the body, the negative retarding force is acting over here, and we have been given the mass of the body and its speed, the initial speed, that is 10 meters per second, and the constant force of 8 Newton directed southward. The body is moving initially in the north direction, and force of 8 Newton is directed towards south. So we can easily calculate the acceleration, because we have been given the mass of the body, and its acceleration is going to be negative, and it only acts for 30 seconds. So if we plot the force versus time diagram, so we will get force of minus, so if we take this direction as north, so force of magnitude 8 Newton is acted for 30 seconds. Is acted for 30 seconds, and after that the force suddenly stops, and after that the body is moving with the constant speed. So similarly we will get the value of velocity at the end of 30 seconds, and so we will have the velocity and we have the time, so we can calculate the position at different instances of time. Now moving on to the next question. A truck starts from rest and accelerates uniformly at 2 meters per second square at time t equals to 10 seconds. A stone is dropped by the person standing on the top of the truck 6 meters high from the ground. What is the velocity and acceleration of the stone? So again the question is of the detaching body. So we should keep in mind about one thing, that whenever the body is dropped from an accelerating body, then the instant it is dropped, the whatever the velocity or speed of the body is from which it is dropped, the body that is dropped has the same velocity. So like in this question we have truck which started from rest, that is the initial speed is 0 and accelerates uniformly at 2 meters per second square and at time t equals to 10 seconds. So after t equal to 10 seconds it should have velocity of 20 meters per second square, 20 meters per second. So the stone will also have initial speed of 20 meters per second in the direction of motion of the truck. Now we have to find out what are the velocity and acceleration of the stone at t equals to 11 seconds. So just after 1 second we have to calculate the velocity and acceleration of the stone. So here after the stone gets detached from the truck, we will have the force of gravitation acting, so it would be moving down also, and it will be moving in the direction of truck also for 1 second. So we have to find out the velocity and acceleration. Acceleration would be just negative of g, that is minus 10 meters per second square. And the next question we have, a bob of mass 0.1 kg hung from the ceiling of a room by 2 meters long is set into acceleration. The speed of the bob at its mean position is 1 meter per second. What is the trajectory of the bob if the string is cut when the bob is at one of its extreme position? So when the bob is at extreme position, then its speed is 0. So the bob will fall vertically downwards like this. So when the bob is here, its speed is 0. So since initial speed is 0, so gravitational force will act on it and it will fall vertically downward. And when the bob is here, then it will have maximum speed. So let us assume that the bob was moving in this direction, so it would follow a parabolic path and fall somewhere here. Now in this question we have a mass of a man of mass 70 kg stands on the weighing scale in a lift which is moving upward with a uniform speed of 10 meters per second. So we have to find out the reading of the weighing scale when the lift is going upward with a uniform speed. So as we have discussed earlier also, when the speed is uniform except in circular motion, then the net force is 0. So the net force on the weighing scale, the reading would be just the mass of the man, and it would be equal to 700 Newton, because 70 kg times 10 meter per second square acceleration, so it would have given 700 Newton. Now in the second question we have downward with the acceleration of 5 meter per second square. So when the lift is moving downwards, net reaction will decrease by the same amount as the acceleration. So the net acceleration of the body will be 70 kg times the net acceleration would be 10 minus 5 meter per second square, and that would give us 350 Newton, or mass that would be displayed on the weighing machine is 35 kg. इसका फोर्स डायग्राम ऐसे दिखेगा. सो बी केस में from the inertial frame of reference, like when we are seeing from the ground, so its mass would be like this. So man 70 kg का है, so 70 times g, the acceleration would be there, and since the downwards acceleration is 5 meter per second square, and the reaction force is this r, and we have to calculate this r value. So 70g minus r would be equal to 70 times 5. I don't know why my eraser is not working. So the r would be equal to 70 times 5 minus 70 times 10, that is g. So I am sorry for this screen error. So r would be equal to 70 times 5 minus 70 times g, and it would give us 350. So since we have taken this direction, that is downwards direction, as positive, so reaction would be obviously in the opposite direction, so it would be minus 350 Newton, or we can say it is 35 kg. I hope you got the solution. So let us go to question number 4.14. In this question we have figure 4.16 shows the position time graph of a particle of mass 4 kg. What is the force on the particle for t is less than 0 and t greater than 4 seconds, and t between 0 and 4 seconds. So here we see that the position time plot of a body is given, and initially the body was not moving, that it was at rest till time t equals to 0 second, and just after time t equals to 0 second, a straight line is there till a. A straight line in position time graph shows that the slope is constant or the velocity is constant. So constant velocity is acting on the body from O to A. Now we have been given the force acting, we have to find out the force acting on the particle for t is less than 0. So here we see that the position is constant, so no force is there, and also from 0 to A or from 0 to 4 second, the net force would be 0 because the body is moving with the constant speed, and when the body is moving with the constant speed and it's one dimensional motion, so we can say that its acceleration is going to be 0, or net force acting on the body is equals to 0. And next question, we have to find out the impulse. So impulse is change in momentum. So impulse as a quantity j would be equal to change in momentum, or we can say p final or momentum final minus momentum initial. So when we have to calculate the impulse at time t equals to 0, we see here that final momentum would be mass times its velocity. Now how to calculate the velocity? Velocity is the slope of this plot, and finding the slope of this plot, we have to find this slope is theta. So it would be 3/4, and that would give us 0.75 meter per second. So velocity we have got. So we see that at time t equals to 0 second, the final velocity is 0.5 second in the positive direction, and initial velocity is 0. So p final would be 0.75 times the mass, that is 4, so it would be 3, minus 0, p initial would be 0, so the impulse would be positive in this time t equals to 0, and at time t equals to 4 we see the opposite case. The final momentum is 0 because the body has stopped, because the position time plot is constant. So we get the negative value of this momentum that was initially. So the impulse imparted at time t equals to 4 second would be minus 3 kg meter per second. Now moving on to the next question. Two bodies of mass 10 kg and 20 kg respectively, kept on a smooth horizontal surface, are tied to the ends of the light string, a horizontal force F equals to 600 Newton is applied to A and B along the direction of string. What is the tension in each string in each case? So in this question, we can visualize it like this. So let us assume that this is 10 kg block and it is attached via a string, and this is 20 kg block. So the force of 600 Newton is applied on A. So in the first scenario, 600 Newton is applied on this body A. So we have to find the tension in the string in each case. So here we see the system of 30 kg, and we can easily calculate the net acceleration of the system, because since it is attached with a string, so it would be both the objects will be moving with a constant acceleration. So when the body moves with the same acceleration, we can assume it as a system. Now this system is of 30 kg and the force is applied on the system is 600 Newton. So we can calculate the net acceleration by dividing the force with the mass. That is, we will get the acceleration of 20 meter per second square. Now this acceleration is going to be same in both the cases. Either you apply a force of 600 Newton on A or on B, because the system would be same. Now what the difference would be there in each case would be the tension in the string. So if we pull body A with 600 Newton, then tension would be different. So let us have the free body diagram of body A over here. So this is tension T, and this is the force applied 600 Newton. So and it is moving in this direction with the acceleration of 20 meter per second square. So here free body diagram says that 600 Newton minus T would give us 20 meter per second square times the mass, that is 10. So this would be T1 when the force is applied on the body A, and now in the case of body B, we will see that when 600 Newton is applied in this direction, we will see that 600 Newton minus again T2 equal to 200 times 20. So sorry, 20 times 20. 20 is the mass of this block B, and 20 is the net acceleration. So we see the value of tension would change over here, and the tension in the string in first case would be twice as much in the second case. Now let us move to the next question. Two masses 8 kg and 12 kg are connected at the two ends of the light inextensible string that goes over a frictionless pulley. Find the acceleration of the masses and tension in the string when the mass is released. So the question here is of a pulley. Let us assume that this is the pulley, and this is the 8 kg mass and this is the 12 kg mass. Now when it is left, we have to find the acceleration and tension in the string. So we will find out the free body diagram. We will draw the free body diagram of both the blocks, and we will see how it is causing the tension and the acceleration. So since the string is same and it is inextensible, so the tension in the string would be same on either side. So we can give the value of tension as T, and we can assume the mass of gravitational acting downwards. So it would be 8g and it would be 12g. Now the acceleration in the case of 8 kg block would be in the upward direction, and acceleration in the case of 12g block would be in the downward direction. We know the direction here because we can see that the 12 kg mass is higher, and even though if we don't know, we can assume a direction of A, whichever way you like, and we will find out the real direction of A upon calculation. If it is positive, then our assumed direction was right, and if it is negative, then our assumed direction was opposite. So the force equilibrium equation of 8 gram block would be T minus 8g is equals to 8a, and that of the 12 kg block would be 12g minus t is equals to 12a. So once we solve the equation, we will get the value of t and a. In the next question, we have a nucleus is at rest in the laboratory frame of reference. Show that if it disintegrates into two smaller nuclei, the product must move in opposite direction. So here we have been given the laboratory frame of reference, that is it is isolated. So here we can apply the conservation of momentum. So we see that when in the conservation of momentum, when a body is moving in a direction, and so the other nuclei must go in the opposite direction to conserve the momentum. Like this, if this is the body and this has disintegrated into two bodies, the initial mass was m and it disintegrated into m by 2 and m by 2. So if one of the mass is moving in this direction, so it would gain a momentum of m by 2 times v, assuming that this is the direction of positive v, and so this would be direction of negative. So in order to conserve the momentum, so initial momentum was the nucleus was at rest, so initial momentum was m times 0, that is 0 kg meter per second. And since one body is moving with the speed of v in positive direction, so the momentum of this body would be m by 2 times v. So this positive momentum must be countered to brought to 0 according to the conservation of momentum, so that the conservation of momentum is valid. Now when it will be 0, when the other mass is having exactly same momentum as this one in the opposite direction, so the other mass must have minus v, so that the summation of momentum remains 0. That's how we can say that the other part must move in the opposite direction. Next, move to the next question. Two billiard balls, each of 0.05 kg, moving in opposite direction with the speed of 6 meter per second, collide and rebound with the same speed. What is the impulse imparted to each ball due to each other? So we have seen previously also, J as the impulse is given as delta P, or P final minus P initial. So since two billiard balls are there, when they would meet, they would exchange the momentum and then they will reflect back. So we have to find out the change in momentum or the impulse. So let us assume that the mass was m and the direction was v. In this direction, that was the positive direction. So initial momentum would be, P initial would be for this ball would be m times v, and the final momentum P final would be m times minus of v, because the direction has changed. So P final minus P initial would be minus of mv minus mv, because P final is minus of mv and pi is mv, so and pf minus pi would be equal to minus of 2 mv. So this would be the impulse imparted on the left ball, and similarly we can find out the impulse imparted on the right ball as well. Let's move to the next question. The cell of mass 0.02 kg is fired by a gun of mass 100 kg. If the muzzle speed of the shell is 80 meter per second, what is the recoil speed of the gun? Again here we have to find out we have to apply the conservation of momentum. So here initial momentum is again 0, as the gun and the shell was at rest. So P initial is equals to 0. P initial of the system, here the gun and the shell is a system, and the final momentum of the gun and the shell must also be 0, and the final momentum is composed of the gun moving in the opposite direction as the shell. In order to find the momentum, we need to know mass and velocity. We know the mass and velocity of the gun. We know the mass and velocity of the shell. that is the mass of 0.02 kg and the velocity is 80 meter per second, and we know the mass of gun. We just need the velocity of gun, so we can equate the product of mass times velocity or the momentum of gun with that of the shell, and we will get the recoil speed of the gun. Let's move to the next question. Let's move to the next question. A batsman deflects a ball by an angle of 45 degree without changing its initial speed, which is equals to 5 km per hour. What is the impulse imparted to the ball? So the question is again same as in the previous two questions we are seeing. So here, if you want to simplify the approach of this question, so it is said that this angle is 45 degree, so this individual angle would be 22.5 degree. Now we have to calculate the impulse imparted, so we have to calculate P final minus P initial. So if you want to simplify this question, so change this speed velocity into the vector form, that is unit vector form, that is I cap and j cap, and simply subtract the momentum, the final momentum minus initial momentum, and you will get the solution. Let's move to the next question. We have been given that the stone of mass 0.25 kg tied to the end of the string is whirled round in a circle of radius 1.5 meter with a speed of 40 revolutions per minute on the horizontal plane. What is the tension in the string? So it is the case of, so this is a string of 1.5 meter, and here is the stone attached. Now we have to find out tension in the string if the stone is rotating around this pole. So we know that when we see from a non-inertial frame of reference, we can say that the tension force is making the stone go around. So it is holding the stone with a force that is equal to the mv square by r. It is called the centripetal force. So we can get the tension in the string as equal to mv square by r. And when we have to find out the maximum speed which the stone can be whirled around, if the string can withstand a maximum tension of 200 newton. So there is a limiting amount of tension or the force that this string can withhold, that is T max is given, that is 200 newton. And we have to calculate the V max. Mass is given, we have to calculate V max by R. R is also given, that is 1.5 meter. So here there is just one variable that is missing, so we can easily calculate the value of V square, V over here. Let's move to the next question. So in this question we have to say it says that if in exercise 4.21 the speed of the stone is increased beyond the maximum permissible value and the string breaks suddenly, which of the following correctly describes the trajectory of the stone after the string breaks? The stone moves radially outwards, the stone flies off tangentially from the instant the string breaks, the stone flies off at an angle with the tangent whose magnitude depends upon the speed of the particle. So it extends the previous question and says that what if the speed is increased from the limiting value to a higher value? So Game Mania has asked, so 200 Newton is the maximum centrifugal force. So centrifugal force is the force that is a concept of non-inertial frame of reference. It is the centripetal force that we are talking about. And with the given question, it is the maximum tension force that this string can withhold. Yeah. it is so as per the question, the string can withhold maximum of 200 Newton. If you replace it with a bigger, much stronger string, then the centripetal force can go much higher as well. So the limiting part here is the string. So the question 4.2 asks, if we break the string or with the increase in velocity or speed, the string broke, where will the particle go and what will the final trajectory of the particle? So so according to the Newton's second law of motion, the particle will move unattended, or because there is no any limiting force that is that will make the body go round and round, so it will move tangentially outwards right after the string breaks. Now question 4.3 says that explain why a horse cannot pull a cart and run in empty space. So we should first clear out why a horse can run on the ground. So the thing is that a horse applies a force on the ground, and the ground gives equal and opposite reaction force. That's why the horse is able to push the ground and move forward. And when there will be no ground, there would be no reaction on the horse legs, and there would be no agent that is pushing the horse, so the horse can't move on its own. The second question is, passengers are thrown forward from their seats when speeding, the bus stops suddenly. So here since the passengers are not bolted strongly and fixated on the seats, they are acted upon by inertia, and initially maybe the bus would be moving with some velocity, some speed, and when the brakes are applied, the bus goes still, but the passenger's body still continues to move in that speed, so it doesn't stop suddenly, it moves forward with some distance and then stops. The third question is, it is easier to pull a lawnmower than to push it. So we have to understand it with the force free body diagram over here. So when you push a lawnmower, your action of force should be in this direction. So there would be two components of force, that is the vertical component and the horizontal component. Now we must understand why it is easier to push a lawnmower or why it is harder to push a lawnmower. So when it would be harder, so when there would be more friction on the lawnmower, then it would be harder to push it. So here we see that when we push the lawnmower, there is a vertical component of force acting, that is adding to the reaction, and the frictional force is the normal reaction times the coefficient of friction. So here the frictional force will increase, whereas in the case where we pull the lawnmower, there will be force acting upward, so this will cause the reaction force to decrease, and thus the friction force will decrease in this case as compared to in the first case, that is in the case of pushing the lawnmower. That's why it is easier to pull the lawnmower as compared to pushing the lawnmower. Now the fourth question is, a cricketer moves its hand backward while holding the catch. So here the question is, why cricketer moves his hand backwards. So the thing is that force is given by change in momentum or impulse. Let us assume we denote the quantity impulse by J by delta T. Now the main motive of the cricketer is to feel less force. So less force can be either you can achieve less force by decreasing the impulse or by increasing the time. So here, since the impulse is not in the control of the cricketer, that is he can't control from which height the ball will fall in his hand, so he has this delta T in his control. So when we will increase this delta T, then obviously the maximum force experienced on his hands will decrease. So that's what the cricketer does. When he pulls the hand backwards, he is increasing the time of catching, that is delta T. That's how he saves his hand, by application of increased delta T and thus decreasing the force. I hope your doubt should have been cleared. If you have any doubt, you can ask. I will leave the chat open for at least 5 minutes and then we will dismiss it. I'm open to questions now. The question says that give the magnitude and direction of the net force acting on a drop of rain falling down with a constant speed. So here, a drop of rain is falling under constant speed. We all know from Newton's first law that a body is at rest, continues to be at rest until or unless there is an unbalanced force acting on it, or a body, when it is in motion, then it will remain in motion with constant velocity until or unless there is some unbalanced force acting on it. So in case it is it is falling down with a constant speed. The speed is not changing when it is falling down. We all know that it is under influence of force of gravity that is pulling the raindrop towards the ground, and also it is acted upon by frictional force